And please mute yourselves. Yeah, the reason why we go for decomposition is because we'll be able to break down the complex structure into simpler ones, and these simpler ones can be easily managed. And whenever I talk about decomposition, understand, see, you've already learned regarding, or at least you've heard about testing and how exactly a unit testing is done, how exactly an integration testing is done. So all these are parts, all the you're able to do a unit testing or you're able to do integration testing, all because you have what is known as decomposition. The other term that I can use for decomposition is modularization. Okay, the other term that you can use for decomposition is modularization. I remember telling you that in case you have a big event happening for decomposition, I remember giving you this example wherein you have a big event happening at your organization. It could be a school or college. What needs to be done is you have a huge team working towards the event, but then you have to divide the work in such a way that every sub team or say every subgroup of this entire lot is given some kind of work. So same way, even when you consider a project, what happens is every project, the entire project is being broken down into various modules, and each of these modules should be working independently, and then later on you have to bring them together. And when you do the testing, I want you to recall what I said about the stubs and the drivers, where the stubs are the dummy subprograms and the drivers are the dummy main programs. I'll tell you a little more about decomposition when I give you an example. Okay, right now just understand the definition. Decomposition is breaking down the entire big lot into a smaller, simpler, manageable piece of code. Okay, and yeah, that's regarding decomposition. And see, one more thing that you can appreciate regarding decomposition is that when you develop these modules independently, the reusability of this particular of the code also increases. You are enhancing the reusability of the modules. When you have modules present, you can simply reuse. You will be learning that as an example. You will learn that as an example. I'll tell you as I proceed with the slides. I'll tell you what exactly do I mean by reusability. Okay. Then coming to the abstraction, or I think I'll quote you the example now itself. See, when you talk, I remember, I think I gave you the example of Intel company, right? Intel is a company which is into the chip designing. So when I say every time the Intel is going to start manufacturing or designing the chip, they are not going to start right from the scratch. They are going to make use of what was there in the existing, in the previous designs of the chip. They are going to make use of the previous designs, and then they are going to make the customization based on the new requirement. Okay, when I say customization, it means you're trying to modify or you're going to change according to the requirement that has come its way. So decomposition is that. So when you have this decomposition, I'm trying to tell you the benefits or the advantage of having decomposition. When you have decomposition, you're breaking the entire big problem into smaller ones, and these smaller modules or smaller units can be reused. The example I quoted was Intel company. Now Intel is into chip designing, as I told you. Instead of starting the entire chip designing right from the scratch, what they do is they make use of the already existing modules, and then they build the new chip on it. They make the customization or they make the changes on the existing one. Okay, so that's decomposition. Now coming to the abstraction. Now abstraction is wherein you reveal what is relevant, reveal the data what is relevant to the others, and hide the
Ma'am,
irrelevant data. Huh?
ma'am, if you don't
Yes.
mind, will you again tell that example for, I mean, Intel one, ma'am, for decomposition?
See, in decomposition, what happens is, okay, the Intel company's example, if I tell you, see, Intel is into the chip designing. Okay. Every time they design a new chip, what I was trying to say is they will not start right from the scratch. Okay, they're not going to start from the scratch. What they'll do is there is a basic framework. There is a basic framework in the sense it's like a skeleton, and over that skeleton only you're going to put in the new whatever new design has to be incorporated. So what I'm trying to tell you is that when a new chip has to be designed, they are not going to start from the scratch. They will make use of the existing design and they will try to customize it. Customize it means change it based on the new requirement it has come its way. Okay. Or to give you a very simple example, the one who asked me, what's your name?
Ma'am, Adi Kartikeya, ma'am.
Kartikeya. By any chance, have you learned C?
No, ma'am.
Okay, you have not learned. Okay, then fine. I thought I'd quote some other example. Um, it's like that. It's basically your reuse. I'm trying to tell you regarding the reusability of a decomposition. Okay, let me tell you a very general example. I mean, nothing related to software or hardware. That's something which you can relate to very easily. See, when you go to this pizza, Domino's pizza and things like that, isn't it? Each one of the section they have a different component. When you make a pizza, how many things are there? You have a pizza base, you have various toppings, you have various sauces, isn't it? All of them are independent of each other. One of them can one of them can make the pizza base. So that's the entire pizza is basically an you know you are going to integrate multiple things in that, isn't it? You first have the pizza base, then you spread the cheese over it, then you put the toppings, and then you have all these sauces going in and things like that, isn't it? This is how the pizza is made, and then you give all those seasoning and things. So in case of pizza also, you can actually relate the decomposition. The decomposition is that one person, you have, let us say, some 4 people there, and you have just one order to be placed. So what happens is one person will make the pizza base. Okay, the other person will probably cut all the toppings that is required. The third person is making the sauce that is required for the pizza. So you have, let us say, three. Huh? So you have 3 different people working on 3 different. Uh, Please mute yourself, students. So you have 3 different people working on 3 different jobs. Okay, and they are independent of each other. It is not necessary that only after you make the pizza base you're supposed to make use of the other things, isn't it? So each of them are independently doing the job and they can be brought together. Now let us say the pizza base is being made. Okay, the topping is still being done. Suddenly the customer comes, he places the order, and based on that order, the pizza is being made. The base is being made, sauce is already present, and the toppings are being cut or whatever that's been utilized. Then suddenly the customer says, he gets a call or something, and he says that I cancel the order, and he leaves. So do you think that pizza base is going to be thrown out? Definitely no, isn't it? The next customer who walks in, he will be making use of the same pizza base. So what has happened here? Whatever module, what is that module? The module here was making the pizza base. That pizza base was reused by somebody else. Okay. Here you
Ma'am, it
cannot.
is like you have told, na, ma'am, assembling of system means different companies' parts like CPU, monitor, like that only, na, ma'am.
Yes, yes, yes. But here, see, when we talk about pizza or we talk about the hardware here, you cannot reuse the same thing. I'm only talking about the designing part. Okay. See, once one piece of hardware is there, one piece of keyboard is there, once that keyboard is sold to somebody else, you cannot sell the same piece of keyboard to somebody else, isn't it? I'm only talking about the coding part. Coding is something that you can always duplicate. You're understanding what I'm saying?
Yes, ma'am.
The code part can be duplicated, whereas the hardware component, definitely you cannot do it, but you can always have the design which can be replicated. That's what I'm trying to say. It's basically reusability. Okay.
Okay, ma'am. Thank you,
Yeah.
ma'am.
Yeah. So coming to the abstraction now. In abstraction, what happens is you try to hide data which is irrelevant and reveal only those data which is relevant to the outside world. I'll give you an example with respect to programming itself. Now I'll just show you. So basically abstraction means you're hiding data. Generally The moment you say abstraction, the first phrase that has to come to your mind, or the first word that should come to your mind, is data hiding. So when we hide the data, then what is the entire purpose of abstraction? The entire purpose of abstraction is that you will not have to reveal all the data which has to be, kept as a, confidential data, or which you do not want everybody to access. In such cases, this abstraction comes into picture. And let us say you do not want people to know that how exactly this, work is done. In that case, you say it is abstraction. This is all abstraction. You're kind of hiding the data, how exactly it has been done. Only thing that you get is you just send the input to a module. Okay, the module performs the job and you get the output. You do not know how exactly it has been done. Okay, the very best example that I can tell you right now, which all of us can relate to, you will also come to know in few months time, the result generation. Okay, in Amrita, what we do is we do not have we do not put the marks, the exam marks outside. It's just the grade that you come to know. I'm only talking about the end semester. Your end semester marks are not known to you, rather your grades will be out. So what happens is what we do is, we teachers, after we correct your end semester paper, we enter the marks into the AUMS software. I've told you regarding AUMS software. It is Amrita University Management System. We put the marks into AUMS software. This AUMS software, what it does is, it will, where am I giving the input of marks? I'm giving it to giving the input of the marks to one module called result generation. Okay, I think I'll just show you one second. Please mute yourself.
Which point should we note down?
You don't have to, just to listen to what I'm saying. That's all. Okay, the slides will be given to you. The slides are self-explanatory. Yes.
Ma'am, can more than one type of computation thinking exist while developing a program?
Yes, of course, yes. Actually, all of them, you can consider them to be independent of each other. Some of, all these are part. I'll just tell you. I'll come to that. Okay, that's a good question. Your question is whether they are independent of each other or they can come into a single module, isn't it?
Yes, ma'am.
Yes, I'll come to that. They are not independent actually. It's everything is a part of a module itself. Anyway, I'll come to that. Wait. So I have a module which is called result generation. Okay, result generation. Now, what will be the input? The input would be the marks. Okay, this is something which is known to the outside world. This is not hidden. Then I need to process this marks. When I process this marks, I require marks and I require the grade range rule. Okay, grade range rule is 90 to 100 is so much, 80 to 89 is so much. That is the grade range rule. These should be applied to the marks. The grade range rule is applied to the marks. Applied grade range applied to the marks. Okay, this is the process that is happening, but nobody knows. So this part is hidden. Okay, the processing is hidden. What is the output? The output would be the grade of a student. Okay, now this part, the one which is in say maroon or something, this is something which is hidden. But at the same time, is it doing the job? Yes, it is doing the job. Which module is it? The module here is result generation. And what is the abstraction? Where is the abstraction part here? The abstraction part is that I am giving the input, which is marks. This is seen by somebody else. I am the end user, isn't it? I enter the marks. So I am able to see that. then the processing happens. I do not know how the processing is happening. I give the input, I just give the grade range rule and marks. How exactly it has been done in the code wise, I do not know. That is hidden from me. So this is the hidden part. And then I have the grade coming out. Will I be able to see it? The answer is yes. Okay. So this is one example that I can speak about an abstraction. I'll give you one more example, which easily we can make out. This is one example I can think of right now for abstraction. And coming to the question which the girl asked, how exactly are all the computational thinking related to one module? There are 4 modules associated here. One is algorithm, the other is abstraction, there is pattern recognition or pattern matching, and then we have the decomposition. The very fact that I'm talking about module, a single module, see, result generation is just a part of AUMS. So here I satisfy the cornerstone of decomposition. The entire AUMS software has been decomposed into various modules. So this is one module. So decomposition is achieved. Coming to abstraction, I am doing an abstraction here. What is abstraction? I'm hiding how exactly the marks is being processed. I'm not showing the data here. So which means that this is abstraction. I am exhibiting, the modularization is also exhibiting abstraction. Coming to algorithm part is, what do you mean by algorithm? You all have, you have all undergone 1 or 2 lab sessions. You know what an algorithm means. Algorithm means you're only telling them how exactly the data needs to be processed. So I can definitely write an algorithm for this. I can say step 1 start, step 2 read marks, okay, and then step 3 read the grade range rule, step 4 process whatever the process is. I can write the algorithm for it, and you can say whatever n something display grade. Then I say step n+1 stop. So I can write an algorithm for this. Okay. Then coming to pattern match,
before reading we have to write declare, na ma'am.
Yes, you have to declare, correct. You have to declare, correct. Thank you. You have to declare and then take the input. So for everything, algorithm is a procedure that you're writing. So that is the process. And coming to the pattern matching means, okay, I'll just come back to this. Did I answer your question? Who was the one who asked me that question, whether it's independent? What is your name?
Sri Harshita, ma'am.
Sri Harshita. Okay. Harshita, did I answer your question?
Yes, ma'am. Thank you.
Yeah. So abstraction is that. And algorithm, you already know, algorithm is a stepwise procedure. All of you are done with it, isn't it? You know how to write an algorithm, all the 3 sections?
Yes, ma'am.
Yes. Okay.
Yes,
So you know what
yes,
an
ma'am.
algorithm is. Algorithm is you're writing the stepwise procedure of how exactly a work can be achieved, or an objective can be achieved. That is algorithm. What about pattern recognition? Pattern recognition is based on the previous existing solution, if the same solution can be used for the next problem. Please mute yourself, students. If you can repeat that particular solution again, the same approach can be applied. Again, I can quote the same example of Intel. Okay, pattern recognition. I can quote the same example. Or for that matter, one more example that I can say is, see, let us say a class, you have got too many, you have some 3 subjects for your course. Let us say maths, PSAT. Please mute yourself, students. Let us say you have 3 subjects for your course. Okay, you have PSAT, you have students, this is disturbing. Please mute yourself. Sanju. Sanju, please mute yourself. Okay. Now coming back to pattern recognition. I told you that you have three subjects. Let us say you have PSAT, you have maths, and let us say you have English. Okay, these are the three subjects that you have. Let us say I'm supposed to find out the average marks scored by the class in PSAT. So what I'll do is I'll collect all the marks, students' marks, and then I divide it by the number of students and I get the average marks. Now, don't you think the same thing can be, same procedure or same process can be applied even for finding the average marks for English, and for that matter, maths also? You can, isn't it? Why? Because I recognized a pattern now. I recognize the pattern that I just have to collect all of the marks and divide it by the number of students. That is the pattern that I use to find out the average marks. The same thing can be applied when I asked for English marks. What I can do is I can use the same code. Only thing is, instead of collecting marks for PSAT, I'll be collecting marks for English. Then the same thing, same code I can use it for finding the average of maths, because instead of English, I'll be making use of math. So this is pattern recognition. Or let us say the same thing, instead of finding the marks, I'm supposed to find out the average age of students in the class. So what I'll do, instead of collecting the marks, I'll collect the age of all the students, right? So which means that I'm trying to match the similar kind. I'm trying to match the similar kind of problem that was existing, and I'll try to reuse that. I'm trying to match the pattern, and accordingly, I can always derive or devise a solution for it. Am I clear on this, students? The pattern recognition? You're basically identifying the problem based on whatever was existing in prior. If you have a solution, then make use of the same solution, or you try to customize it based on your existing problem, even if it is related. Am I clear on this?
Ma'am, what is matching in this, ma'am?
Yes, ma'am.
See, matching is you're trying to match the similar kind of problem. You are trying to recognize and match, basically. You're trying to recognize and match the similar kind of problems. See, okay, I'll put it this way. See, when you go for this biometric, have you ever seen this biometric attendance? Or
Yes.
yes, the biometric attendance, what we do is, I am able to say that because we have this biometric attendance for the staffs. So what happens is, when I press my thumb on the device, what is happening? It is recognizing a pattern. So here the pattern is getting recognized. I am an employee in Amrita, and my thumb impression is already taken. Okay, so when I press my thumb, what it does is, it is first going to recognize that it is something which is existing. Okay, and the second thing it does is, it is going to, so which means that the pattern is recognized now. And the next thing it does is, it is going to match my thumb impression with the corresponding name. So when I press my thumb onto that biometric, what happens is, the pattern is recognized. It is matched with my name, which is Srividya, and I get a message on the device saying, "Welcome, Srividya." You're getting my point?
Yes, ma'am.
Okay, so this is pattern matching, pattern recognition and matching. So the code which runs for my thumb impression is same code which is running for the other staffs who walks into the campus. So it is basically recognizing the same code is being used. It's the same code. It's just that the sequence that the code gets is different. Please mute. Please mute yourself, students. Nagarjuna, please mute.
Excuse me, ma'am.
Nagarjuna, please mute yourself. Do you have to ask any question? Yes? Somebody said, excuse me, tell me what.
Ma'am, is abstraction only concerned to data hiding, ma'am?
Yes, it is to do with data hiding and encapsulation. I'll come to that example next. Next, I thought of telling you that itself. Okay. So are the terms clear to everyone?
Yes, ma'am.
Yes, ma'am.
Okay.
Yes, ma'am.
Yes. Tell me, I'm listening.
Ma'am, for pattern recognition, is the data should be stored initially, ma'am? Means
Yes,
to
yes,
recognize the same pattern.
yes, 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 yes.
Okay, ma'am.
Okay. To give you an interesting example, students, please mute yourself. Otherwise, it becomes disturbing and will not be able to do a good job. Please, please understand. Unmute yourself only when you have to ask the question. Start. Then I say declare A, comma B, and then I say sum. And then I say I'm trying to tell you what exactly abstraction is. I'm trying to show you abstraction and modularization. And actually the algorithm is also included in this. I've not followed the exact syntax, okay? I'll come to that in the later classes. Okay, we have something in the black font and we have something in the maroon font, okay? So here what I'm trying to do is I'm trying to tell you what exactly a modularization and what exactly data abstraction is, okay? So what I'm trying to do is I'm trying to write a program in such a way that I have to write, okay, I think I'll write one more. I will say sub. Minus. Okay, I have okay. Now I have three different pieces of code here. Okay, one is in black, maroon, and blue. Now what I'm trying to do is I'm writing one single program. Okay, I'm trying to exhibit what exactly modularization is. I write one simple program here, which is kind of depicting or say a simple calculator which does only the addition and subtraction of two numbers. It's finding the sum and difference of two numbers. Okay. So what I have to do is, which means that it is expected to do two different operations. So for each of the operation, I write a separate module. I repeat, I write a separate module consider these modules to be different units. I have a huge team. Let us say, I'll say just 4-member team. Okay, not huge team, 4-member team. And I give this program. I ask you to write a program in such a way that you modularize. So what you'll do is all the 4 of you will not sit on the same program, same line of code. What you'll do is you would say that 2 people just take care of addition, 2 people take care of the subtraction, and let us say and after that you integrate them together. So what you will do is one team A, what they'll do is they'll write a module for adding 2 numbers. For adding 2 numbers, what needs to be done? You require 2 inputs. Let us say X and Y. Look at the maroon font now. Okay. You say that the team A, what it does is it writes the module for adding 2 numbers. So what would you do? You require to add 2 numbers. How many inputs you require? You require 2 inputs for adding 2 numbers, right? So here I write the input. Okay, X and Y are your input. Then what is the operation? It has to be X plus Y. So I put that X plus 5 and I put it in one more variable. I hope you remember what variable means. Variable is the identifier which can hold a particular value at one instance of time. Okay, so that is getting stored here. So X plus Y it does. X and Y are the inputs. It performs the operation. It performs the operation and return. I'll tell you what exactly this means. Just now, as of now, just understand so much. What happens to team B? Team B is also writing the code for finding the difference. It's called sub. They call that operation to be sub, that module to be sub. What are the inputs it requires? Again, it requires 2 inputs, X and Y. It performs that. I mean, it takes that, and X minus Y is the operation it does. After it performs the operation, it again stores it in another variable called result. Okay. So here now this part is over. So my modules are ready now, but I remember telling you that the modules cannot work. The unit cannot work until they are called to work. I repeat what I say because I'll be making use of this term call later in the later classes. When I say 2 modules are ready or 2 units are ready, you remember what is a driver and a stub? I told you, no, once the units are ready and your driver is not ready, your main program is not ready, that is when you write a dummy main program, which are called the drivers. So same way, why did we write the dummy main program? Because I told you that these units or these modules will not work until they are called. Somebody has to call them. Add function, I have to call this add function. Only then this add function will work. When I say I'm supposed to find the difference between 2 numbers, I have to call this module called sub or unit called sub. Only then it is going to perform the job. So somebody has to call it. Who is that somebody? That somebody is this main program. It's like the head of the family. This head of the family, only when he calls all these members, only then it is going to perform the job. Otherwise, this is not going to perform the job. Okay. So therefore, we write one main program. Please mute yourself, please. So we have to write the main function here or main program. So in main program, what do? I first have to understand what are the variables that I require. So in this main program, in this sub programs, do you see anywhere where I write read here in this examples? You do not see a read, isn't it? But I have to give an input for these operations. So what I'll do is in the main function itself, it's like main function, take these are the 2 numbers, you please add this number and get the results back. Then for the same number, you may say that same 2 numbers, I'll give it to team B and I'll say that, come on, find out the difference for these 2. So it is the main program which is going to send the input for it. It is not necessary always that the main does. Okay. You will have various variations. I'll come to that later classes. Okay, when we read regarding modularization, I'll tell you in detail. This is just a small example. So here what I'm doing is I start the program. I declare whatever variables I require. Then I say read A and B. Let us say I take the values 8 and 4. These are the 2 values that I take as an input. Okay, these 2 values I take as an input. 8 and 4 are the inputs that I give. Then what I do is I say add A comma B. Now what does this add A comma B do? It is as good as saying add 8 comma 4. Okay, I'm writing this as add 8 comma 4. Now what does this 8 comma 4 do? When I call, this is called calling a function, or this is called, this particular line of statement is called calling. What am I doing here? This 8 comma 4, I am passing it to a function. What is that function? That function is add. Okay. Now when I do this, what happens is, the control will come here. From here, it will go to this particular point. Are you understanding, students? Do you understand what I'm saying?
Yes.
Yes, ma'am.
Okay, good. So here the program always, the execution starts from the head of the family. Head of the family is your main program. This is called a main program. So it will start, it will declare, read A and say B. We already put for add. So which means that the head of the family is passing these numbers to these members. And what is the job of this member? This member, whatever value it has got. Now what happens? What is the value of X now? What is the value of X now?
8.
8. Good. 8. X is going to have 8 and Y is going to have 4.
4.
Okay. X is going to have 8 and Y is going to have 4. So this value gets added. After it is added, so what does the result have now? What will the result have?
12.
Result?
12. 12.
It is going to have 12. Okay. So what happens next is, see, it has got 12 in it, but this member is keeping to itself. It is supposed to return it back to the, see, after it performs the job, it has to report to the head of the family, isn't it? The main, it has to tell the main program that the result is 12, isn't it? So that is the reason why we have this statement called return result. Are you understanding, students? This return means, return is a keyword in program. This is not capital letter. It has to be small letter. I mean, I've not followed the syntax. Okay. So when I say return result, what it does is, after it performs the job, it is going to return the result. Return the result. To whom does it return? Whoever has called it. In this case, who has called this add function? This add program, correct. So what happens is, it is also, this result is also going to be returned to the main program. But here I do not have a container to hold this result. What is the result value? 12. So to store this 12 also I require a container, isn't it? The variable. So what I'll do is, I will write an equal to sum equal to. I'll just add one more line of statement. I'll say, let's reduce the font a little. Okay. Now what happens is, I'm going to put sum equal. So now what happens is, only the, see, I'll again come back to the control of the flow. It will be where all these read AB, then forget LHS right now. You understand what is LHS, RHS, right? I'm not talking about LHS. I'm only talking about RHS. What is your RHS? It is add A comma B. So the control goes here, it performs all the job, then you have the result here. Now the result will be assigned to, the sum. It will be assigned to the value sum. Are you understanding? Now what will be the sum value? The sum value will now be equal to 12. Are you understanding?
Yes, ma'am.
Yes? Okay, good. Then what I'll do is, I will display what is there in sum. Display sum. So that gets displayed. This should be in black, because this is a part of my code. Whatever I've
Should we
written.
again write sum is equal to 12 under the sum is equal to add?
No. See, understand this. The one which is in green is not my code. The green font, I'm just telling it for you to understand. Okay.
Okay.
Students, my code is only the one which is in black. My code is only in maroon. The one in blue is also my code. The one which I've written it in green is just for you to understand. Okay.
Okay.
Okay. So now I finish my display sum. Then what happens is, so my sum has been displayed. I get on screen, I'll get sum as a value. Now come to the
Excuse me.
subtraction. Tell me.
It can be display or printf, no, ma'am.
Anything, yes. Print
Okay.
F means it becomes C. Okay, you can write display, you can write output, you can write print, anything is fine. For algorithm, it is absolutely, you have no such restriction.
Okay, ma'am.
Okay, so here again, okay, so this part is over. Till here we have done. Okay, next come to this particular line. I think I'll put the numbers to this so that it becomes easy to tell you which is the part of my code, which is not a part of my code. Okay, my fifth line is this, and I come to the sixth line here. So the same thing happens even here. So here when I say sub 8,4, so where does the control go? Now where does the control go? Now the control will come to this particular piece of code. Okay, now what is the value of x and y? The same thing as what we have here. The same thing happens here, isn't it? The same thing happens here. Now result alone will change. Result instead of 12, it is going to have, what is the difference between 8 and 4? You get 4 as the answer, right? So again, I get the return result. So for return result, do I have to make any change here in my main program, students?
Yes, ma'am. You have to add sub equal to
Or I already have a variable here, diff. So I'll make use of diff here, difference.
Yeah.
Okay, yes. So I make use of the keyword difference here, not keyword, sorry, the variable. Okay, then the control from here. The value of result, which is 4, that is getting passed to difference. And again, I am going to display. So this difference, what is the value the difference is going to have? Difference is going to have the value 4 in it. Okay, and I need to display them. Say display diff, and this is my 7th step, and this becomes my 8th step. Am I clear on this, students? Oh, my arrows and all have gone hayway. Okay. So is this clear, students? So now coming back to what I was trying to say. Now, when I say I'm calling the function sum here, is my main program, the main program even bothered to know what exactly is happening inside this? No, the answer is no, isn't it? Are you understanding, students, what I'm trying to tell you? The main program only does send the input to value to it, and it will also get back the output. But is it knowing what exactly is happening here? Is it x plus y? Or even if I change here, I'll just give, instead of x plus y, I may call this function add, but I may change my operation to be x star y, that is product of y. Is this main program coming to know about it? The answer is no. Are you understanding, students, what I'm saying? Students, please respond.
Yes.
Yeah. So this is abstraction. This is abstraction. What this add function is, this is modularization, this is abstraction, and this is also a kind of this is also algorithm. We have written an algorithm for it, isn't it? We have written the entire algorithm. These are modularization. This is a modularized program. How do I say it is modularized program? Because I have a separate module for add, I have a separate module for sub, and these modules are called by the main function. So this is modularization. Am I exhibiting abstraction? The answer is yes. How? Because inside this module, what operation is happening? I'm The subtraction doesn't know. See, they are totally independent. Don't you see that add and subtract are totally independent? They have no interaction at all. So this is independent. They are hiding, the add function is hiding its operation from main, it is hiding it from subtraction. You're getting my point? So this is one of the examples that I can quote with respect to abstraction, with respect to algorithm, and also the modularization. Am I clear on this, students?
Yes, ma'am.
Okay. So
Yes, ma'am.
Yes, ma'am.
great. So we'll stop here for today. We'll try to write it the same program in a better way in the next class. Okay, and we'll start off with the next chapter. So I think we've come to the end of this chapter. I just have one more slide to go probably. I just have to, it's basically to do with the definitions. We've already done with the definitions. So we'll come to that. This is all examples. Okay. We'll come to this and we'll start off with the next chapter on.
Ma'am,
So shall we wind up now? Tell me.
ma'am, so decomposition, abstraction, algorithm, and pattern recognition come under design and implementation, is it?
Yes, 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 yes.
Okay. And that is
Design.
a part of computational thinking in return.
Yes, yes.
Okay. So it comes under the software development life cycle, the computational thinking.
See, you cannot really narrow down by saying that it is only a part of software. Okay? You cannot always say that it is part of software. See, even when you come to the hardware, computational thinking, see, even the hardware components, when you have to implement or say develop a hardware component, you have the software backing it. Okay, so you cannot necessarily say that it is only a part of software development life cycle. Even when you develop a hardware, you have a software component existing there. So you cannot simply say that it is only a part of software development life cycle. Even you can simply say that it is a part of development life cycle. The computational thinking is a support for the development life cycle. Okay. Yeah.
Thank you, ma'am. Thank you so much.
Anything else, students? Shall we wind up?
Hello, ma'am. Good morning.
Yes,
Can you hear
thank
me?
you, ma'am.
Yes. Somebody's asking something. Yes, ma'am.
Ma'am, can you please tell the process like to swap variables with temporary swap two numbers with temporary variable? Like first is start and then we declare a is equal to and b is equal to. Then what will come after that, ma'am? In the process.
A, B, and you have to also declare one more temporary variable. Call it T.
Okay, ma'am. After that.
Wait, I'll just write the thing. You declare A comma B comma T. Then let us say your A is 4 and your B is equal to 5. What you need to do is, okay, this is your A. What you need to do is you have to take your T with A. Sorry, you have to take T is equal to A. So now what will happen? T is going to have 4 in it. Then you say A equals B. A equals B. So your B is going to have, what is the value? 5. Then I'll say B equals T. So which means that your B is going to have 4. So you can see that the values of A and B are swapped. Do you see that? Oh, sorry, this is A. Now A is going to have 5 and B is going to have 4. Okay.
Oh, okay, ma'am. Ma'am, and like to convert degree Celsius into Fahrenheit, we can only write the formula and it's enough now, ma'am.
Yeah, formula you have to write. Yes.
Okay. Thank you, ma'am.
Okay, thank you.
Ma'am, actually, you have given a homework, no, ma'am, on lab.
Yes.
To write logarithm and algorithm.
Yes.
For that, we have wrote something, ma'am. Will you check that on lab only or today only, ma'am?
Yeah, in the lab I'll check, man. Okay.
Okay.
You have just 3 more minutes for your next class also. Okay.
Okay.
Yeah.
Thank you.
Thank you, man. Thank you. Have a nice day, all of you. Thank you, students. Bye.
Thank you, ma'am.
Thank you. Thank you, ma'am.
Thank you, students. Bye. Have a nice day.
Thank you, ma'am.
Yeah, bye.